Calculating masses in reactions. In the fascinating world of chemistry, understanding how to calculate the masses in the substances involved in a reaction is fundamental. Whether it is determining the amount of product formed or figuring out how much of a reactant is required, mastering this skill is essential for interpreting and predicting chemical processes. In this lesson, we will break down the process into straightforward steps, guiding you through the method to calculate the mass of a product or a reactant in any chemical reaction. With clear explanations and practical examples, you will gain the confidence to tackle these calculations with ease. Let's dive into the lesson and explore the step-by-step approach to calculating masses in reactions. Example 1. Finding the mass of the product. In this reaction, 2H2 plus O2 produces 2H2O. Calculate the mass of water H2O produced when 4 grams of hydrogen gas H2 reacts completely with oxygen O2. Step 1. Write the balanced equation. Here is the equation. 2H2 plus O2 produces 2H2O. To determine if a chemical reaction is balanced, each element must have the same number of atoms on both sides of the equation. That means reactants and products. Hydrogen H, 4 atoms on the left, 4 atoms on the right. Oxygen O, 2 atoms on the left, 2 atoms on the right. Always check the balance before moving forward. Step 2. Calculate the total mass. Find the total mass of element or elements and the product or products by using the relative formula mass. Number of elements in hydrogen gas and in water. Number of elements, hydrogen gas H2. 2 times 2 is equal to 4 and its mass is 4 times 1 is equal to 4 grams. Number of elements in H2O, hydrogen H, 2 times 2 is equal to 4 and its mass is 4 times 1 is equal to 4 grams. Oxygen O, 1 times 2 is equal to 2 and its mass is equal to 2 times 16 is equal to 32 grams. Total mass of 2H2O is 4 plus 32 is equal to 36 grams. So 4 grams of hydrogen produces 32 grams of water. Step 3. Conclude the mass. The mass of H2O from 4 grams of H2 is 32 grams. This is the answer for the question. Example 2. Finding the mass of a reactant. In this reaction, 2Na plus Cl2 produces 2NaCl. Calculate the mass of sodium required to react with 71 grams of chlorine gas. Step 1. Write the equation and balance it. In this question, the balanced equation is already given. 2Na plus Cl2 produces 2NaCl. Step 2. Calculate the molar mass of sodium and chlorine. Atoms and masses in sodium 1 times 23 is equal to 23 grams per mole. Atoms and mass in chlorine Cl2 2 times 35.5 is equal to 71 grams per mole. Determine the number of moles of chlorine. To find the moles of chlorine is equal to the mass of chlorine Cl2 divided by molar mass of Cl2 is equal to 71 divided by 71 is equal to 1 mole. Step 4. Use the mole ratio to find the moles of sodium, Na. In this equation, 1 mole of chlorine reacts with 2 moles of sodium producing 2 moles of sodium chloride NaCl. Step 5. Calculate the mass of sodium. 1 mole of chlorine Cl2 is equal to 71 grams. 1 mole of sodium is equal to 23 grams. In this reaction, 1 mole of Cl2 reacts with 2 moles of sodium. That means 71 grams of chlorine reacts with 2 times 23 grams of sodium, 46 grams of sodium. The answer is 46 grams of sodium. Example 3. Finding the mass of a product, a complex reaction. In this reaction, CaCO3 produces CaO plus CO2. Calculate the mass of calcium oxide CaO produced when 100 grams of CaCO3 decomposes completely. Step 1. Write the balanced equation. CaCO3 produces CaO plus CO2. The equation is already given and it is balanced. Step 2. Calculate the molar masses of the substances. Molar masses of CaCO3 equals to 1 calcium plus 1 carbon plus 3 oxygen equals to number of atoms times relative atomic masses equals to 1 times 40 plus 1 times 12 plus 3 times 16 is equal to 40 plus 12 plus 48 is equal to 100 grams per mole. Molar mass of calcium oxide CaO is equal to 1 calcium plus 1 oxygen equals to 1 times 40 plus 1 times 16 is equal to 40 plus 16 is equal to 56 grams per mole. Step 3. Determine the number of moles of substances. Moles of calcium carbonate CaCO3 is equal to mass of calcium carbonate CaCO3 divided by molar mass of calcium carbonate CaCO3 is equal to 100 divided by 100 is equal to 1 mole. Moles of calcium oxide is equal to 56 divided by 56 is equal to 1 mole. So in this reaction, 1 mole of calcium oxide CaO is produced from 1 mole of calcium carbonate CaCO3. Step 4. Calculate the mass of calcium oxide. Mass of calcium oxide is equal to mole of calcium oxide CaO times molar mass of calcium oxide CaO is equal to 1 times 56 is equal to 56 grams. So mass of calcium oxide CaO produced in this reaction is 56 is the answer. Thanks for watching. If you found this video on mastering mass calculations in reactions helpful, don't forget to like, subscribe and share with others who might help benefit. Thank you. Bye now.